says he's thinking back to the time we solved a big problem. We had to figure out a way for our friend Juniper the worm to come with us on our vacation to the lake. So we designed and built a boat for her. And he says we had so much fun on our trip. I agree. I'm so glad Juniper got to come with us. Hey Squeaks, do you remember another time we solved a problem? We were talking about how people called engineers solved problems. And we realized I had a big problem that we could solve together. You know how things are around here. We're always asking questions and building things and using our imaginations and learning. But today we're going to learn about people who get to do all of these things all of the time. We're going to learn how to think like engineers. An engineer is a person who makes something that solves a problem. And hang on just a second. Excuse me. Okay, engineers make things that solve problems, and something that solves a problem is also called a solution. For example, let's say there's a city near a river, and across the river, there's another city. People who live in one city need a way to cross the river to get to the other city. To solve this problem, an engineer might design a bridge, one that's big and strong enough to safely hold a lot of people, plus all of their bikes and cars as they go across. So the bridge would be the solution to the problem. Now, when they're trying to find a solution to a problem, engineers don't just make a bunch of guesses. They follow a series of steps to come up with the best possible solution. Those steps are ask, imagine, create, and improve. Let's see what kind of work an engineer does in each of these steps. First, asking simply means asking questions about the problem. Lots of questions. These questions might be things like, what's the problem? How will I know when I've solved it? And what can I use to solve the problem? Engineers do the best they can to find answers to all of these questions. Then they move on to the next step. They imagine. I bet you're pretty good at imagining. And if you are, you're already thinking like an engineer. Engineers have great imaginations, and they use them to think of many solutions to a problem. In fact, they usually come up with a whole list of solutions. Sometimes an engineer might draw a picture of each idea to see how it would fit together and to help them imagine how it would work. Then they pick the idea they think might work the best. Gosh, excuse me again. Okay, all right. Next comes my favorite step. After engineers imagine some solutions, they create. Usually, engineers will start by making a model of what their idea would look like in real life. A model is something that looks or acts like the thing in the real world. And if you've ever used plastic bricks to make a building, then you've made a model of a building. Building a model bridge, for example, takes a lot less time and money than building a real bridge. So an engineer can use the model to see if their idea actually works and solves the problem. But even if the idea does work, engineers still aren't done. They look at the model very closely to see if they can improve it or make it better in some way. In the case of the bridge, they might see if they can design a bridge that's safer or stronger. And if their idea doesn't work, engineers don't give up. They can use parts of their idea that did work to come up with a new one, or they can go back to their list of ideas and choose another one to build. So those steps again that all engineers use to solve all kinds of problems are ask, imagine, create, and improve. Now, are you ready to start engineering? Good, because we have a real problem that needs a solution. My back is really itchy, and it's itchy in this weird spot right here in the middle, and I can't reach it. I bet if we work together, we can think of a solution to my problem. So let's take the same first step that engineers take and ask some questions. First, what is the problem? Well, I can't reach where my back itches, and that's a problem. So let's ask another question. How will we know if we've solved the problem? That's easy. When I can reach the itchy spot on my back and scratch it, then the problem is solved. Okay, let's ask one more question. What things do we have around here that we can use to make our solution? Well, Squeaks and I looked around the fort to see what we could find. We have a couple of rulers, some modeling dough, a pencil, a plastic fork, the cardboard roll left from a roll of paper towels, and some tape. These are some of the things we can use to come up with an idea. Okay, let's move on to step 2. imagine. It's time to put our thinking caps on to see what kinds of back scratchers we might be able to make. Squeaks and I are each going to take some time to draw a picture of a solution that we think might work. Why don't you use that time to do the same thing? Then, the next time we meet, we can share our ideas and then do the next steps that engineers do. We'll build our back scratchers, test them to see if they solve the problem, and then improve them to see if we can make them even better. But don't take too long because my back is really itchy. Don't worry, Squeaks. We will get to the solution, but it's worth pausing to think about it, don't you think? It's not just about having a solution, it's about how you come up with it too. Okay, let's see how we finally solved my itchy back problem. Welcome back to the fort, where today we're going to solve some problems. If you were with us last time, you'll remember that we were learning to think like engineers. Engineers are people who make something to solve a problem. And the thing that they make to solve the problem is called a solution. Squeaks and I were looking for a solution to the problem that I had, and I still have it. My back is super itchy, and the itchy part is in a place that I can't reach. Since we were thinking like engineers, Squeaks and I decided to follow the same set of steps that engineers use to solve problems. Do you remember the steps that they used? You're right, Squeaks! The first step is ask. We asked and answered questions about the problem, like what is the problem and what can we use to solve it? Then we went looking around the fort to find stuff we could use to build our solution. And here's what we found: some rulers, modeling dough, a pencil, a plastic fork, the cardboard roll from a roll of paper towels, and some tape. Now, we don't have to use all of this stuff, but we can only choose from what's here. All right, the second step is right again, Squeaks! Imagine! We used our imaginations to think of solutions to the problem of my itchy back and decided to build back scratchers. Then we decided to take some time to draw some ideas for back scratchers using a pencil and paper. Now, I think I'm done with my sketch. Squeaks, how are you doing? Great, because this itch is really annoying. Do you remember the next step that engineers take? You're on a roll, Squeaks! You are right. The next step that engineers take to solve problems is to create. And that means it's time to build our back scratchers. We'll look at our drawings and do the best we can to make what we've drawn. And we're done! After engineers have made their solution, or at least a model of it, the next step is to test it. In engineering, testing means trying out an idea to see if it solves the problem. Let's try my back scratcher first. I used some tape to fasten the plastic fork to this pencil. All right, here it goes. Well, the back scratcher doesn't quite reach the itchy spot on my back. It's just too short. So my idea doesn't do a good job of solving the problem. And that's okay, not all ideas work. If an engineer's idea doesn't work, they pick another one to test. Engineers don't give up, and neither do we. So let's test Squeaks' idea next. His design uses modeling dough to stick a fork to the end of a ruler. So let me give this one a try. Well, it's definitely long enough to reach my itchy spot. Oh, it works. Uh-oh. Whoops. It looks like I pushed a little too hard though. The fork fell off the end of the ruler. I guess the dough wasn't strong enough to make it stick to the ruler. But that's okay, because we have one more step to take. That's right, Squeaks, improve. Improve means to make better. What engineers do, and what we need to do, is to look at our idea to see if we can make it better. While the second back scratcher worked, it did fall apart. So let's see if we can improve it so that it doesn't fall apart. My back scratcher wasn't long enough, but it did stay together. I used tape to hold the fork onto the pencil, and Squeaks used modeling dough. I wonder what would happen if we used tape to hold the parts of Squeaks' back scratcher together instead of the dough. Let's try it and see if this improves our second idea. Okay, we did it. Now let's test it. It works! It is long enough to reach the spot on my back, and it's staying together. Using the tape instead of the modeling dough improved our solution. Now, if we wanted to, we could try to build a totally different solution with the same stuff to see if we could come up with an even better back scratcher. We could try using the paper towel tube to see if it would make it longer, or see if there's a way to make one that folds up so I could fit it in my pocket. There's no limit to the number of solutions we could try. But for now, I'm just glad to not have an itchy back anymore. I agree. I think there are lots of different ways we could have solved my problem. And it's fun to think about what those could have been. Having an itchy back is one kind of problem, but engineers solve problems small and big. Even problems as big as, how can we go to Mars? How do we get there? With a rocket, of course. Do you remember when you and Mr. Brown made paper rockets right here in the fort? Let's take a look.
Oh, hi Squeaks. I've been so excited about the rockets flying to Mars the last few months, I decided it was time to build my own rocket. This rocket would be way too small for me to travel in. This straw rocket is a model of a big rocket. It looks kind of like a real rocket and works in a similar way too, so it can help us learn about how real ones work. Remember how rockets lift off into space? That's right. Hot gases rush out of the bottom of the rocket with so much force that the rocket shoots up into the sky and eventually all the way to space. My straw rocket works in a similar way. I made the rocket by wrapping paper into a tube around a pencil. Then I taped it into shape around the pencil and taped it closed at the top. Finally, I replaced the pencil with a straw. Now it just needs something to push the rocket forward. Ready to see? The air I blew into the straw launched the rocket. It acted like the hot gas that pushes a real rocket into the sky. I've tried a few designs for my model rocket. The first design was just a tube, but it didn't really fly well. I tried adding paper fins like the metal ones on a real rocket. Now, my model flies pretty well, but I want to go really high. What do you think could make it go farther? Oh, great idea. Squeaks thinks the rocket might fly farther if we could get more air into it. And that gives me an idea. Let's use a stomp rocket. I built this myself out of a PVC pipe, strong tape, and an empty plastic 2-liter bottle. You can find instructions for how you and a grown-up helper can build your own stomp rocket in the description. To make our rocket, we'll need construction paper, tape, and scissors. First, we'll roll the construction paper into a tube just big enough that it fits loosely over the PVC pipe. We'll use the tape to hold it in shape. We can tape paper fins and a cone on the top too, so it looks just like a real rocket. Now, let's go outside and try out our stomp rocket. Oh, we're not actually gonna stomp our rocket model. We're gonna stomp on the launcher. That way, we can blow air into the rocket a lot better than I could just by breathing. This 2-liter bottle goes on the other end of the PVC pipe, and I've already taped around it so no air can escape. When we stomp on the bottle, all of the air inside of the bottle will need to escape. Where do you think it will go, Squeaks? That's right. The air will get pushed really quickly through the pipe and push up on the rocket really, really hard. Before we try it, I think we should move outside so we can launch our rocket safely. Ready? 3, 2, 1, lift off! Wow! What did you think of our first flight, Squeaks? I think we could make our stomp rocket go even higher though. What do you think, Squeaks? How could we improve this design? That's a good idea. If the air is leaking out somewhere, there won't be enough to push the rocket, so it won't fly as high. If we tape up places that could leak, it could improve our design by making sure all of the air is pushing the rocket up. Let's go make some changes and see if they help our model fly even better, Squeaks.
Maybe your rockets wouldn't have made it all the way to Mars, but sometimes it helps to make a smaller version of your solution to help understand how it works. And sometimes you make something that doesn't solve a problem at all, but you can still fit all the parts together to understand how to make even bigger and better things. Do you remember when we made the coolest machine ever? I sure do. Oh hey, you're just in time. Squeaks and I were just getting ready to test our new cheese serving machine. You see, Squeaks and I both love eating cheese together, and we also love going outside and having adventures. So we invented a way to keep our cheese cool while we're out, and then put it on the table so it's all ready to eat by the time we get home. We've already learned about simple machines that help us get things done by making our work a little easier. Our invention uses two of them, a lever and a pulley. Check it out! To make our machine work, the first thing we do is put our cheese down on top of this piece of cardboard. The cardboard is sitting on top of a glass of ice, so the cheese stays nice and cool. Then, while we're outside, the ice melts and turns into water. So this string that's been caught under the ice cubes comes loose, which will activate our lever. A lever can help you lift heavy things. It's made out of a long, straight object, like a ruler or a board, balanced on top of another object called a fulcrum. One type of lever you might have used before is a seesaw. You might not be able to pick your friend up off the ground, but if they're sitting on a seesaw, you can push down or sit down on the other end, and up they go. Our lever is made out of this board, balanced on top of a water bottle. This end of the lever will flip the cheese onto the table for us, and this end, the one with the sharp pencil on it, will fall onto the balloon and pop it. The balloon has a heavy marble inside, along with some confetti just for fun. And when it pops, the marble will fall through this funnel here and turn on the fan. Then the fan will blow this rubber ducky across our little canal here until it bumps into this marble. The marble falls down this track and knocks over these dominoes, which bump into another marble over here, and that marble rolls down this track, and it'll knock our golf ball off the tee, which will release this string, which is part of our pulley. That's the other simple machine we're using in our invention. A pulley is a wheel with a groove along the middle of it, where a string or rope fits in. Our pulley has a golf ball on one side and a little cup of orange juice on the other. Squeaks loves orange juice. And now that we're home, it's about time for the ice to melt and release the string. Ready to see if our machine works? Oh, look, the string is loose, and here comes the pencil. Let's see if the rubber ducky makes it. Yeah, and there go the dominoes, and your orange juice, Squeaks, and some cheese for both of us, and a nice glass of ice water for me. Our invention works, buddy. You're right, Squeaks. Instead of building this whole invention, we could have just put our cheese in the refrigerator earlier and taken it out when we got home. That would have been easier than building this whole invention, but building it was so much fun. See, our invention is a type of Rube Goldberg machine. Rube Goldberg was a real person, an artist who was born over 100 years ago. He went to school to study engineering. That means using science for designing and building. But what he really loved was drawing. So he became a cartoonist and used his engineering knowledge to draw cartoons about some really wacky inventions. These cartoon inventions used a chain reaction. That's when one action causes another thing to happen, which causes another and another. Just like one domino makes the next one fall over, and then the next and the next. And all of Rube Goldberg's very complicated reactions were invented to do something very simple, like wipe your face with a napkin, or open an umbrella, or button your shirt. To an engineer, the best machine is the simplest one. A machine with lots of complicated parts is a lot more likely to break than a simple design with just a few parts. Rube Goldberg was using his cartoons to laugh a little bit about machines, which were supposed to make everyone's lives easier and simpler, but the machines in his cartoons were really complicated, and that made them funny. And his inventions had some really silly parts, like frogs, umbrellas, cats, parrots, banana peels, and sometimes even people. I don't know if Rube Goldberg ever used a rat in one of his machines, Squeaks, but maybe we can. Rube Goldberg's inventions were imaginary. They only existed in his mind and in the cartoons he drew. But today, people remember his silly ideas by building their own Rube Goldberg machines. You can make one too, and you can use science to do it. When you're inventing your own Rube Goldberg machine, First, you'll need an idea for a simple job that needs to get done, like hanging up your jacket, or turning off the light, or anything you can think of. Then you'll need a design or a plan. It's a good idea to write down or draw what your machine will look like and how it will work. Having a plan will help you figure out how to put it together. Here's the design Squeaks and I used for our machine. You can go back and learn with us about levers, pulleys, and other simple machines to give you some ideas. And remember, when it comes to Rube Goldberg machines, sillier is better. You may want to see if a grown-up can help you with your design. Once it's finished, you can gather the materials and build your machine together. It took us a long time to get our machine working exactly right. Our inventions went wrong a lot of times before we got it working. But then, when it finally worked, it was so cool. So what do you think, Squeaks? Should we go eat the cheese and then get some more and run the machine all over again? Ah, Rube Goldberg, truly a great engineer. Engineers can make things that are silly or serious, or both at the same time. The only important thing is to try to solve problems. In fact, it's important to remember that there's never one right answer in engineering. Engineers often compare and test multiple ways to solve problems. And no one is better at looking at problems in different ways than our friends, Bill and Webb.
Whoa! What's going on? What's all this quacking about?
Well, we were in Sam the Bat's observatory, and there was a button really high up on the wall that we really wanted to push to see what it would do.
Yeah, and neither of us could reach it. But I told Bill about something called engineering that could help us.
Wow, that's a great idea. Engineering is how people develop solutions to problems. First, engineers identify a situation they want to change, and then they design and test solutions to the problem.
Yeah, it sounded cool.
So you identified the problem, you couldn't reach the button, and you decided to approach the problem using engineering. What happened next?
Well, we each designed a high-up button pusher to help us try to reach the button.
But I think mine is better than Bill's.
Quack, 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 quack.
All right, settle down, you two. I bet both of you came up with some great designs. Why don't you show me what you made?
I have my design right here. You can see that I nailed several long pieces of lumber together. I can reach some high buttons.
Wow, Bill. I can see that your design is very strong and stiff. It would be great for reaching things that are far away like that button, but it also looks very heavy. I can imagine it might be hard for you to lift this one up.
Yeah, it was a little hard to handle when I was testing it in the observatory.
Well, look at mine. It's nice and lightweight. Just tape and a stick at the end.
Webb, yours does look very light, which would make it very easy for almost anyone to use. But it's a little bit floppy, don't you think?
It was very easy to lift up, but you're right. It was kind of hard to control.
Well, you know, the best part about engineering is that there can be more than one way to solve the same problem. You both came up with solutions to the problem, and both of them had strengths and weaknesses when you tested them out. Let's think about what those were. Bill, yours was strong but hard to use. Webb, yours was easy to use but super flimsy. But that's okay, because finding a really good solution to a problem sometimes takes a few tries. Even engineers have to test their designs to see what's working and what's not working and make them better. Orville and Wilbur Wright were two brothers who made the first airplane to fly in the sky. But before that, they tested many designs. First, they made gliders that could only glide through the air instead of flying. Then they added engines so those gliders could stay up in the sky, and they had an airplane. Maybe we can take a little bit from each of your designs and make an even better high-up button pusher.
What if we use the tape from mine to tape small, lightweight pieces of wood together?
Yeah, then it would be strong like mine, but lightweight like Webb's design.
Great ideas, you two. Let's build a new design that combines a little bit from each and see how it does.
Ta-da!
Wow! Look at this great design that you worked together to make.
Yeah, it's still made of strong wood, just smaller pieces.
The small pieces of wood help make it lightweight so anyone can lift it up.
Great work, you two, using your engineering and teamwork skills to create an excellent solution to a problem. Let's head to the observatory to test it out.
Yeah!
They arrived at such a great solution together, didn't they? But while pushing buttons and flying to Mars are important things, there's one other reason to solve problems. For fun, of course. For example, when you're playing with bubbles, they always pop before you're ready. So wouldn't it be way more fun if we designed bubbles to be unpoppable? Let me show you. All right, ready, Squeaks? Aw, I love blowing bubbles with you too, Squeaks. Oh, hi there! Squeaks and I have been having fun with bubbles today. It's one of our favorite things to do together, and it's really simple. A soap bubble is made with just a few ingredients: water, soap, and the most important ingredient, air. When you blow air into soapy water, all the ingredients mix together. The water and soap cover the ball of air like blankets, and together they make a round shape that can float around in the air, at least until the bubbles pop. Oh, good question, Squeaks. Why do bubbles pop? Well, water is really sneaky. As soon as you put it in a bubble, it tries to escape. And when the water gets away, the air trapped inside the bubble can follow it and escape too. And then, what do you think happens? Yes! The rest of the bubble falls apart and it goes pop. The soap holds the water inside as long as it can, but eventually every bubble bursts. Oh, I know, it is true. Soap bubbles do pop pretty quickly. An unpoppable bubble would be pretty fun. I wonder how we could make one. I know, let's try an experiment. I think if we make the soap thicker, maybe that will help to keep our bubbles around longer. There are lots of thick bubble soap recipes that we can make here at home. What do you think, Squeaks? Should we try one out? We'll need 4 tablespoons of water and 1 tablespoon of dish soap, just like our first bubble solution. Now we'll add our special ingredient, 2 tablespoons of sugar. Oh, good question. The sugar should help the bubble. It's going to help make the soap layers of our bubble really thick. I'll stir until I can't see the sugar anymore. All right, it's time to compare our bubbles. We'll count how many seconds it takes one of our old bubbles to pop, and then see how many seconds it takes one of our new bubbles to pop. First, our old bubble. Wow, not bad. That bubble lasted 30 seconds. Now let's see how the thicker bubbles do. Wow, that bubble lasted way longer. The thicker bubble lasted 90 seconds. That's 60 seconds longer than the bubble without any sugar. Ooh, I would love to do more bubble experiments. There are lots of bubble recipes we could try. We could replace the sugar with something like corn syrup or glycerin. And if we get our hands wet, we could even try holding the bubbles. Thinking like an engineer can be so much fun, and I'm glad we got to do it together. Next time we notice a problem we can solve or something we can change, let's be engineers again. And you too, what kinds of things can you change by thinking like an engineer? Think about it. And if you want to keep having fun with me, Squeaks, and all our friends, be sure to subscribe, and we'll see you next time here at the Fort.